Welcome to The Explainer. We're jumping right into a rapid-fire masterclass today on soil and foundation selection, specifically geared for the Florida General Contractor Project Management exam. If you're gearing up to conquer this test, you already know that understanding what happens beneath the ground is just as absolutely crucial as what you build above it. So let's dive right in.
Here's the million-dollar question in construction. Why do seemingly strong buildings suffer catastrophic settlement failures? Well, the answer almost always lies right there in the dirt. Down here in Florida, contractors are constantly battling notorious, weak sandy soils and incredibly high water tables. The stakes are massive, and the exam writers know it. A poor foundation choice, that leads to slab cracking, failed inspections, and a whole lot of liability.
Here's our quick roadmap for this explainer. First, evaluating soil conditions, then choosing shallow foundations, followed by opting for deep foundations, and finally, navigating those common exam traps. Okay, part 1, evaluating soil conditions, the ground rules. Before you even think about pouring a single drop of concrete, you absolutely have to know what you're building on. It really comes down to a hierarchy of stability. At the very top, the absolute best case, you have stable rock, which obviously has super high strength. As you move down the ladder, you get into type A, then type B soils. And finally, at the very bottom, you hit type C soil. Type C is cohesive soil with very low strength, or granular soils that just aren't dense, like sand. And guess what? Florida has a ton of type C soil. Also, keep in mind that things like water, vibration, or previously disturbed soil can downgrade your soil classification in a heartbeat.
So, when you finally get your hands on that geotechnical report, you aren't just skimming it. You are hunting for these exact essentials. First, you need to identify the soil type. Is it cohesive, like clay that sticks together, or is it cohesionless, like sand and gravel? You've got to know the bearing capacity, which is just how much load the soil can actually support safely. You're looking for density and compaction needs, moisture content, and, crucially for Florida, the groundwater and water table levels. A high water table is going to drastically affect your excavation's dewatering needs and ultimately your foundation stability.
Now, here's a highly tested term you absolutely must know, the Proctor test. The exam loves testing your knowledge on compaction. The Proctor test is a lab test used to establish the maximum dry density and optimum moisture content of a soil. Why do we even care about this? Because properly compacted soil drastically increases its density and load-bearing capability. If you skip this step, or if you get it wrong, you are literally inviting settlement, slab cracking, and foundation movement. Which brings us to a massive high-yield number for the exam, 6. To control the amount of settlement, fill material must be placed in layers not more than 6 inches thick. Lock that number in your brain. You can't just dump tons of dirt into a hole all at once and hope for the best. It's got to be placed in thin, 6-inch maximum layers, usually right near its optimum moisture content, just to achieve that maximum density we were just talking about.
Moving right along to part 2, choosing shallow foundations, working near the surface. Let's contrast the why behind these choices. Why go shallow versus deep? Well, shallow foundations are used when you're lucky enough to have good bearing soils right near the surface. They cost way less and are incredibly effective for solid ground. Deep foundations, on the flip side, are a must when you're dealing with weak or compressible soils. Think expansive clay or loose sand, especially when coupled with really heavy building loads. They entirely bypass that weak surface stuff to transfer the loads deep underground. Grasping this core logic is absolutely essential for the scenario-based questions you're going to see.
So what are your actual shallow options? You're looking at spread footings, isolated footings, continuous footings, and mat slabs. A mat slab, for instance, is like a giant snowshoe. It's a massive, thick concrete slab supporting the whole structure, just spreading the weight over a huge area. All of these are designed to distribute the structural load over the competent soil right near the surface.
Part 3, opting for deep foundations, the heavy-duty rescue. But what happens when that surface soil just isn't strong enough? The engineering behind deep foundations is honestly pretty fascinating. We're primarily talking about piles and caissons here, and it's crucial to differentiate exactly how they work. Bearing piles act like massive underground columns. They transfer the building's load all the way down to their tip, resting directly on solid rock or a super dense stratum. Friction piles, they're totally different. They transfer the load along the entire surface area of the shaft, using the dirt's natural grip and friction to hold up the weight. We also use caissons and we use pile caps to tie multiple piles together when we need to support massive column loads. So let's see how this actually translates to the exam. They're going to give you field conditions. and you have to know exactly when to pull the trigger and switch from shallow to deep. You make that switch when 1. The surface soil is obviously weak or compressible. 2. The structural loads are exceptionally large. 3. A high water table or scour exists, meaning moving water might actually wash away your supporting soil. Or 4. The competent strata, that really strong rock or dense dirt, is located incredibly deep underground. If you see any of these red flags in a question, you are definitely looking for a deep foundation answer. And that leads us right into part 4, navigating common exam traps. Don't get tricked.
The test writers love a good curveball, don't they? So here's a massive trap you need to avoid. Thinking that just because a building is tall, it automatically needs a deep foundation, or that a short building only needs a shallow one. No way. Foundation selection is fundamentally a soil and load decision, not simply a building height decision. Think about a massive, heavily loaded, single-story warehouse built on pure swamp muck. That is absolutely going to require deep piles. So don't let a brief description of a building's appearance fool you. Always look straight at the soil conditions they describe in the prompt.
Here's another really common scenario. The exam loves testing your judgment on code compliance and overall safety. If the load-bearing value of the soil is even slightly in doubt, the building official can and totally will require a geotechnical investigation. Remember our overall exam strategy here. When in doubt, the safest, most logical, code-compliant answer almost always involves verifying conditions, pausing the work, or getting a professional engineer's input. You never ever guess on soil stability.
To wrap up the hard data portion, let's rapid-fire some bonus high-yield numbers related to earthwork and excavation. Because, you've got to dig before you can build a foundation. OSHA takes this stuff very seriously. At 5 feet deep, trench protection systems are strictly required. Hit 20 feet deep, your sloping or benching has to be specifically designed by a registered professional engineer. For Type C soil, which we know is the least stable, the maximum allowable slope is 1.5 to 1. And if you're excavating in sand less than 20 feet deep, the maximum angle of repose, which is basically the steer memory.
And that brings us to our final check for today. If your Florida site has weak, compressible soil and a high water table, which foundation are you choosing? Think back to that roadmap. You bypass the weak surface. You account for the water. You go with a deep foundation like piles or caissons. Boom, you've got this. Take these frameworks, apply them logically to the scenarios, and you are going to absolutely dominate the soil and foundation questions on your exam.